Hey everyone, today we are completely demystifying a piece of technology that quietly powers a massive chunk of the entire internet, Nginx. In this explainer, we're going to break this down in detail, but we're doing it in really simple words. Think of Nginx as this ultimate multi-tool. It's essentially a waiter, a security guard, and a traffic manager for your website, all rolled into one. Now, have you ever actually wondered how massive websites manage to handle thousands or even millions of users at the exact same time without the whole system just completely crashing to a halt? I mean, when you think about the sheer chaos of web traffic, how do big companies manage it so seamlessly? Well, the secret ingredient behind the scenes of those incredibly fast, stable websites, it's almost always Nginx. Okay, here's our roadmap for today. 1. Meet your traffic manager. 2. The 6 main jobs. 3. The secret to speed. 4. Key terms and configurations. And finally, 5. Essential Nginx commands. Let's dive right in. Section 1. Meet your traffic manager, bringing order to server chaos. So, to explain server traffic in simple terms, imagine your server is this massive office building. Without Nginx, everyone just enters the building directly, right? Visitors wander the halls, knocking on random doors. It's just total chaos. But with Nginx, you suddenly have a highly efficient receptionist, a security guard, and a traffic controller right at the front door. It checks exactly who came in, decides which floor or server they need to go to, and checks if they're even allowed in the building to begin with. Moving on to Section 2, the 6 main jobs. What exactly does Nginx do? All right, out of all its jobs, the reverse proxy is arguably the absolute most important concept you need to grasp. A reverse proxy is simply a middleman. Basically, Nginx stands completely in front of your backend applications, whether you're running a Python app, Node.js, Java, you name it. The user never talks directly to your app. No way. Instead, Nginx receives the requests first, completely hides your backend servers, handles all that complex security, and then forwards the traffic internally. It's an incredible shield for your applications. But, what happens if one of those hidden backend servers gets completely overloaded? Well, that's where Nginx acts as a load balancer. Let's say 3,000 users show up literally all at once. Nginx distributes them across multiple servers using 3 really clever methods. It can use round robin, just sending traffic one by one down the line. It can use least connections, intelligently sending the next user to whichever server is currently the least busy, or it can use IP hash, which ensures a specific user always goes back to the exact same server, which is super useful for keeping people logged into their accounts. And on top of being a web server, a reverse proxy, and a load balancer, it has 3 other absolutely essential jobs. First, it's an SSL/TLS handler, meaning it acts as that little security padlock in your browser, perfectly managing your HTTPS connections and encryption. It also acts as an incredibly fast static file server for things like your images and PDFs. And crucially, it's a caching server. This means if 10,000 users all want to see the exact same image, your app doesn't have to generate it 10,000 times. Nope. Nginx just stores a copy the first time and instantly hands out that cached version to the next 9,999 users. That massively saves your CPU power and boosts speed. All right, Section 3, the secret to speed, Nginx architecture explained. To really understand the secret to this speed, let's think about a waiter at a restaurant. Traditional servers, like Apache, operate on a process or thread model. Think of this like a restaurant where one waiter handles exactly one customer. If you have 1,000 customers, well, you need to hire 1,000 waiters, and that eats up all your memory and RAM. But Nginx, it uses an event-driven architecture. In this model, you have one incredibly smart waiter who can effortlessly handle thousands of tables simultaneously, completely without breaking a sweat. And looking at this head-to-head comparison, it clearly shows why big tech companies absolutely love Nginx. Because of that event-driven architecture we just talked about, the RAM usage is significantly lower. While older servers are, good, Nginx provides excellent handling of static files and performs flawlessly under high, heavy traffic situations, where others might completely choke. Now, inside the software itself, the architecture is divided really simply. You have a boss, known as the master process. The master process reads all your rules, starts the system, and controls the whole shebang. Below the boss are the worker processes. These are the actual workers out on the floor that handle your users' HTTP requests, manage the connections, and fire off the responses. Okay, Section 4, key terms and configurations, speaking the language of Nginx. So, to actually use this software on your own servers, you're going to need to know these 3 core building blocks. First up is the server block. This tells Nginx basic settings like, hey, listen for traffic on port 80. Inside that, you have location blocks, which tell Nginx exactly what to do when a user asks for a specific folder path. And finally, you have the upstream block. Think of this as your address book. It's where you define those hidden backend servers so Nginx knows exactly where to send traffic for load balancing. And if you're hunting for these settings on your Linux server, here are the absolute most important folder paths you'll need to memorize. Your main boss configuration file, that's always at /etc/nginx/nginx.conf. Now, if you're on an Ubuntu or Debian system, your individual website configurations live in the Sites Available and Sites Enabled folders. But if you're on a Red Hat or CentOS system, you'll want to look inside the conf.d directory. Almost there. Section 5, Essential Nginx Commands, taking control of your server. All right, let's look at the simple terminal commands you actually need to manage Nginx day to day. The absolute most critical takeaway here is the difference between these commands. When you change a config file, you might be tempted to just use restart, right? But watch out. That completely stops and starts the service, which drops your users. Instead, always use sudo nginx-t first. This tests your config for any spelling or syntax errors. If it gets the green light, then you use the reload command. Reloading applies your new configs instantly with zero downtime. Literally, your users won't even notice. So let's pull everything we've learned together by following just a single click. A user opens your website. The internet's DNS finds your server's IP address. Boom! The request hits Nginx first. The master process quickly checks those config files we just talked about, makes a split-second decision to either send a static file from cache or forward it to your app as a reverse proxy, and then the worker processes fire the response right back to the user. You know, if you take away just one thing from this entire explainer today, just remember this simple, perfect sentence. Nginx is a smart traffic manager for web servers. It really is an all-in-one powerhouse. When you add together a lightning-fast web server, a secure reverse proxy, a highly efficient load balancer, a CPU-saving cache, and an SSL manager, you get Nginx. It takes in requests, protects your applications, balances heavy traffic, serves your sites, and just drastically improves your speed across the board. So now that you understand in detail how Nginx keeps the chaos at bay with its single smart waiter architecture, the only question left is, with Nginx handling your traffic, security, and speed so seamlessly, what incredible application are you going to build behind it? Keep exploring, and we'll catch you next time.